Hi, I can't hear you. Um, hold on, let me. It's not working. Stop video. It might be my computer. I don't know. I can't hear you.
Can you hear me now?
Yeah, now I can. All right. Ah, I
was-
thought it was my computer.
No, I was muted. Sorry about that.
All right.
Linda just entered.
Okay, good. Hi. I kind of forgot to tell anybody about this last night, but Mr. Wayne told me I could take the Zoom meeting, so
Okay.
I'm doing it. But
Sounds good.
yeah, I'm eating my
I
breakfast.
can see your ceiling more than I see you. Do you not want me to see you?
Better?
Yeah, that's better. Thanks.
Okay.
I just saw the top of your head.
Yeah. Well, my house is kind of a wreck, so I don't want to show too much.
I know what you mean.
Yeah. But anyway. Mm. Well, I figured, you know what? He told me I could do this. But I
Right.
told him I'm going to do a lot of meetings, so.
Good morning.
Hi.
Good morning, Glenda.
How are y'all?
Good. Daniel just joined too. I don't see you, Glenda. Are you not showing us you?
No, I think you don't need to really see me. I'll be here listening
Okay.
if you don't mind.
No, of course not.
Mm.
Daniel is there. Hi,
Good morning.
Daniel.
Good
Hi.
morning.
Hi, Daniel. Oh, wait. I don't think you can hear me yet.
You can hear me now. Sorry about that.
Oh, that's okay.
Good morning.
Good morning, everyone. How are we doing?
Good.
How are y'all doing?
Oh, not too bad. Chasing grandkids and go nuts teaching classes at Tech. So
Oh, yeah.
everything's on Zoom.
I'll be sending you a list today, like after this meeting, Daniel, a list of our calendar items.
Take your time.
Do you want it in Word, PDF? What do you want?
I don't care. It's just
Okay.
something I can read.
Okay. All right.
I have to go run and do a couple things. I'll be right back.
All right. See you.
You get to watch me eat my breakfast.
We can get you out of it if you don't want everybody to watch you. We can.
That's
get you-
okay. I don't care.
Okay. All right.
We'll just watch your kitty cat in the background.
Oh,
Aw.
nice.
Jude
Yeah.
and Christopher have added now.
Yeah, that's Gandalf. That's
And,
funny.
Good morning, Christopher. Connecting.
Yeah, he's connecting.
Mhm.
All right. Mm. Gandalf.
Quit. June.
Mm.
Daniel's gone. Christopher. Are you waiting, Christopher? Can you hear me?
I can hear you. Can you
I can hear
me?
you.
I'm just
And
trying
I
to get
can
my
see-
headphones to work.
Oh, okay.
I like the cats.
Aren't they great?
Mhm.
Yeah, he has a great background. Okay, June can't hear. Let's see, June. Hi, Sienna. You're unmuted.
How's it going?
Good. We're trying to help June. June, can you hear us now?
Yeah.
Let's see. All right. We're just waiting because Steve's not here yet. And if we go out after 40 or 45 minutes, I'm going to send you another link to re-meet. Does that make sense?
Mhm.
Yes,
Okay. Is that what I should do, Glenda?
I think that's great.
Okay. And June says, I have a message that the browser does not support using the computer's audio device. Oh. June. Can you see?
Christopher, what happened to your team today?
Well, Jordan Pickford happened. Man, I detest that spazzy little fool.
That first goal Everton scored was pretty.
Yeah, it was. They're Ancelotti's doing a great job there, and they've been able to sign some good people. So there's hope. There's hope for them. They just need to get rid of Pickford. He's going to be a boat anchor around their neck if they don't.
In here?
I'm still seething. Sorry.
That's okay. I'm trying to get June on.
I figured you would be as kind of. I'm a Man City fan. I've been aggravated at them all year.
Well, I don't know how they can spend so much and still be leaky in defense. I don't know what's going on there.
Yeah.
It's so frustrating, I would imagine.
The company left and they haven't been able to fill his shoes.
Well, those are big shoes to fill too, though,
Yeah.
admittedly.
Whose iPhone? Communal. Who's communal? Who are these people?
Computer
June?
audio. Good morning.
Hi, oh, there you are. This must be you. Let's see, Steve. I recognize your voice.
Yep, mine it says communal. I
There
am
we go.
communal.
Oh, you're communal. Okay, great. We're waiting on people to come, and I'm trying to help one person be able to hear us. So if you'll just hang on 1 second, we'll get started. We'll get started pretty quick. Oh, iPhone raised hand. iPhone, who are you? Get in touch with the owner of the computer.
I think it's possibly Sherry.
Sherry, okay.
I
And
think.
there's Sandra. June is having technical problems. She can't hear because she's got some new computer. Anybody know how to help her?
She might have a microphone symbol on her keypad. If she hits that microphone symbol, it should unmute her.
Okay.
On my keypad, it's also F4.
Okay, I'm writing that to her.
Okay.
Oh, not Sherry. Sorry, that was supposed to, Sherry, that was supposed to go to June. Sorry, you guys.
Okay.
June. All right, well, we'll go ahead and get started. What time is it? Anybody know what time exactly?
9:02.
9:02, okay. See, Sherry's raising her hand. I'm admitting Derek. Yes, Sherry. Hi, Derek.
I'm not doing anything.
Sherry? What?
I'm not doing anything.
Oh, okay. It says your hand is raised.
Okay, I don't know what to do about it. I'm very.
Oh, it's okay.
technical.
I'll lower your hand. I'll lower your hand.
Hey, thank you.
All right. You think, I think we'll go ahead and get started, everybody. This is Steve Devine. You might recognize him from KCBD Channel 11 Weather, and he's going to be the host. So I'm about to turn over the session to him.
Good morning, everyone. Can you hear me okay?
Yes, sir.
All right,
Yes.
good.
Um,
I just wanted to, a brief introduction. I do the weather, one of the meteorologists over at KCBD. I have lived in this part of the country for about 40 years now. I moved to southeastern New Mexico back in 1980 and came over here in 1999, over here being Lubbock. So been out this way for quite a while following the weather. Do want to mention that this, what we're doing here this morning is not something that I typically do. I've just come out of quarantine. Voice is recovering a little bit from that. So as I said, this is not, what we're doing here this morning is not something that we typically do. This is my second Zoom session ever. So I'm going to get into it, and at some point, I'm sure that we'll have time for some questions. So I want to start by launching my screen here and talking a little bit, share my screen with you, and talking just real
see if
quick
you can share it
about-
now. Can you share it now, Steve? Yeah.
Yes. You can
All
see it
right.
now? All
There we go.
I'm going
Right.
to expand it. I'm also not really a PowerPoint person. This is about the third
It's
one
okay.
I've done ever. But anyway, just a quick recap about some things that I'm sure that you probably remember from school, that directly and indirectly, the sun's energy is what drives the weather and the climate across the planet. And as we look at this, of course, the seasons, just a little graphic reminding everybody about the changing seasons and the tilt of the earth, when we're getting less sun energy, more sun's energy. Of course, in summertime, we're getting more. So I do want to point out one thing about the changing seasons that sometimes we don't think about. And that is that when we're in the summer season, of course, the sun is just about directly overhead. Sometimes it's actually north of the zenith for us. That is, even the southern exposure of buildings will get some direct sunlight at the height of summertime. So that B, those three lines there that are labeled B, indicate the sun's position. So the sun's rays perpendicular to the ground at that point. So all the energy coming in from the sun at that point is concentrated in a relatively smaller area, as opposed to those three lines at the top that are labeled A, and those indicate, for instance, we're at the height of winter time, and because of the tilt of the earth, that same amount of energy that's coming in is spread out over a larger area. Not just that, but right where the label says long distance, the sun's rays are traveling through more of the Earth's atmosphere because it's at an angle, or the rays are coming in at an angle. And because it is traveling through more of the atmosphere, we're looking at more of that energy being scattered by the particles in the atmosphere, molecules in the atmosphere. So again, even less energy is going to be striking the Earth at that point. So talked about the sun. This is called the sun's incidence, by the way. And uneven heating, and the reason that I'm getting into this so much is that the uneven heating of the ground and water creates differences in air pressure. So seeking balance, the air is going to be flowing from one point of the Earth to another point on the Earth. This satellite radar really is irrelevant. This is a video that I had done a little while ago, and so it's starting off a little bit different than what my topic is here at the moment. But mentioned that the air is seeking balance. So in this case, I'm highlighting a cold season low pressure area. And when we have the low pressure, the air has been rising, so air is flowing into that. For us, if we have a strong low pressure area, for instance, the one that's shown here near the Gulf of Alaska, that tends to be preceded here by a southwest flow, which tends to warm us up. Now, as that low moves to the east, in this case, I moved the low from the Gulf of Alaska out to the Great Lakes region, then the same flow could begin to tap some much colder air over Canada and pull it southward into our area. Now, this is going to show a little bit El Nino, and I'm not going to talk much about El Nino right now, but I will come back to that just a little bit later. But I mentioned the difference in the air pressure. So that's what will be coming up here next. And in edit mode, build mode in the PowerPoint, I could figure out how to advance the video real easily. In play mode, like we are now, I couldn't figure out how to advance the video. So just have to wait for it here to move on.
Oh, you're doing great.
Going to come back, thank you. Going to come back to the El Nino, La Nina pattern here a little bit later. But when I mentioned that the air will be trying to maintain balance or equal balance, that can be over a small scale area or a large scale area. So this is showing kind of a large scale area when we have a strong low pressure area moving across the northern part of the United States, tapping that colder air. As we head into the summertime, a lot of times we have what's called a Bermuda high, and that will typically, that's a reverse circulation than the low. So that's going to tap air that's more to the south of us, potentially from the Gulf of Mexico. So I'll come back to that here in a little bit later, a little bit too. So Kipper gave me a few things to talk about, and one of those were some of the daytime and nighttime temperature drivers. So on the screen right now are some of those. So the temperature variation during the day, for instance, from the low to the high, that's referred to as the diurnal. So the cold fronts coming in and warm fronts, mentioned that southwest flow, that typically brings in warmer air. Low pressure areas tapping the cold air to the north of us, bringing in the cold fronts. We had one on Monday, we had another one on Thursday. We'll have another front, although a little bit weaker, coming through the area tonight. Other drivers, things to consider: cloud cover. How much cloud cover? How high are those clouds? What type of are those clouds? Is there precipitation or not in the area? The humidity, higher humidity typically will result in lower daytime temperatures and also warmer nighttime temperatures, because that humidity is sort of like a blanket. So at night, it helps to keep some of the heat trapped rather than allowing it to escape into space. During the daytime, it helps to cut down on the amount of energy reaching the ground, so that results in somewhat lower temperatures. Of course, everything else being equal. Now, cloud cover actually does the same thing. And we have the winds to consider. When we have a light wind, our temperatures at night typically will be colder as opposed to when we have a strong wind. However, if we're talking about a strong cold front coming in, then that wind is accompanied by some colder air. Other things that may affect it, smoke and even dust in the sky. So those things can cut down on the amount of energy striking the ground again during the day, at least by very small amounts, but still it can have a small effect on the daytime temperature, keeping it slightly lower than it otherwise would be. And the reverse again is true at night with anything that's sort of like a blanket, cloud cover, very humid air mass, or even dense smoke, dust, that can help to trap some of the heat closer to the ground level so it doesn't get quite as cold as night. Urbanization. I don't know if you've ever heard of the heat island effect or the urban heat island effect, but everything that we build up, blacktop, parking lots, roadways, concrete, interstates, the buildings themselves that we're in, even the things that we have to everyday life, driving cars, running air conditioners and heaters, those things are all generating heat. So whenever, for instance, whenever we're using electricity, heat is also being generated. But the buildings, the concrete, the masonry, the asphalt, those things collect heat during the day. So during the night, they start to give off some of that energy. So what happens with the heat island effect is that when we're built up like in a city, as opposed to rural areas, we tend to get hotter during the day with those things that help to collect the heat, because in turn, the sun's energy, when the sun's energy is coming in, it doesn't heat the air very well. That's not a good transfer of energy to the air directly. What it does is when the sunlight's energy hits an object, such as the ground or everything that we have built up, those rays are then converted into energy, heat energy, which in turn heats the air in contact with the ground, the buildings, and everything else. So everything that we do helps to generate some additional heat. So we tend to be a little bit hotter during the day, a little bit, not much, but where it really shows up is in the nighttime temperatures. Again, because those things start to give up the energy overnight, as opposed to a rural area where we don't have those things. We have natural, it might just be dirt, but it could be grasses and trees. Those things they don't collect as much energy during the day. So the ground and those objects typically are already going to be a little bit cooler. They don't have the heat energy stored that everything does here in town, for instance. So that's another big deal in terms of how that affects temperatures during the daytime and the nighttime. Spent a long time on this slide, but there are a lot of things here. This is my outline. So irrigation. Irrigation adds humidity to the air. And again, that humidity can act as a blanket, helping to, everything else being equal, higher humidity will result in slightly lower daytime temperatures, slightly warmer nighttime temperatures. There's another thing, and it's called interdiurnal temperature variability. Diurnal is from day to night. That interdiurnal is day to day. So if we have a really hot day one day, the following day is already going to have some heat energy in the system. So if it's a really hot afternoon, the night is going to be warm. We're going to start off quite warm in the next morning. And that means we kind of get a head start on that day's heating. So it's not, of course, at midnight, it doesn't just start all over. It's just this constant flow from one moment to the next. Main processes driving Texas weather and climate. Let me see, I think I may have skipped. Let me just make sure. So, cover all of those. Okay, there was one other thing that I wanted to mention on the temperatures, that more than half of the weather stations that are considered reliable in the world, more than half are located in the United States. Now, in the United States, those temperature stations have shown a slight decrease in the maximum temperature. That's average. There's also, and also slightly warmer nighttime temperatures. So what overall, what that means is that the spread between the low and the high temperature for the day is a little bit lower than what it was, say, even 100 years ago. And one of the things to keep in mind there, well, I'll come back to that, sorry. Let's get on with this one, talking about the main processes driving Texas weather and climate. Its location, just like in real estate, location and location. So because of where we're located on the globe, but specifically in the United States, our weather is affected by a couple of different geographic features, the mountains, the Gulf in particular. So coastal areas typically end up with more precipitation than do inland areas. And see if I can remember how to start this, the little pointer right here. So you can see some very heavy rainfall. This is showing up with those purples so that we're looking at perhaps 80 or more inches of rainfall on average annually. And then in the Gulf Coast region, those blues are about 30 or more inches. You see some of the darker colors right here around Florida, the East Coast right in there. And then of course across Texas, notice the range that shows up here from the darker blue or from the medium blue, if you will. So potentially 30 or more inches of rain out over Southeast Texas. And then as you go towards far West Texas, out towards the El Paso area, we're looking at rainfall amounts of less than 10 inches, annual average. We are, of course, on the dry side of that, with the temperature showing, with the precipitation showing up here on this map. It's coming in at around 16 to 20, which is pretty close for Lubbock, because right now our annual precipitation average is 19.12 inches. That's what's considered average for us at this time. So far this year, we've picked up a little over 10 inches, and that's a little bit more than 5 below the average. We are in a drought, and you've probably heard of that. So we've only had about 2/3 of what's considered our typical precipitation up through this point in the year. So quite a bit of difference across Texas. This is another map that's showing average annual precipitation. The little dots are weather stations. Some of the reporting stations on the original view of this map, you could actually, it was interactive, but this is just a closer view across the Lone Star State. The amounts may vary a little bit here from the map that I just showed you, slightly different sources, and sometimes they're comparing slightly different things. But again, that overall trend, more precipitation generally out to the east of us. Normally, if coastal area, we would expect to see more of that heavier precipitation go ahead and extend all along the coast. But a couple of different things that are going on here. So, of course, one of them is our hurricanes, tropical weather systems, whether they're a tropical storm, a tropical low, hurricane. This messy map is showing historical hurricane tracks, that hurricanes that have come in from the Gulf and have moved into the Texas area. And it's very difficult to see the Southeast Texas area, but roughly right in this general vicinity, Southeast Texas. And that's really where you'll see most of the tracks crossing. Now, there are quite a few that move across South Texas. On the other hand, notice us. Now, we sometimes get the remnants of some tropical weather in our area, but systems that are still named and have their true tropical characteristics, very, very rare for those to move into the West Texas area. So the Gulf is considered part of the Atlantic Basin, the Gulf, the Caribbean, and the Atlantic Ocean when we're talking about tropical weather. This is just a little wider view of the same map, again, showing the tracks coming in off the Gulf. But again, you can see how really South Texas, coastal areas, inland a little bit. This particular map is another map showing historical hurricane tracks, but it also shows Eastern Pacific storms in the lower left-hand corner of the picture. So once again, we're not looking at individual storms here, just at that overall pattern, how the tropical systems favor coastal areas of Texas, but especially Southeast Texas, without them really affecting our area much at all. I forget the name of the storm, 1942. 1940 sometime. We had, I think, 42 inches of rainfall that year with the remnants of a tropical storm moving in. So this is just Hurricane Delta, the latest hurricane that came in. This was the forecast from the National Hurricane Center on the 6th of October. And the forecast at that time had the storm coming into southeast Louisiana. It ended up actually coming more into southwest part of coastal Louisiana. But again, that was very close to that track. This was, again, early October when that forecast was made. For Texas, mentioned that our location relative to the Gulf, but also to the mountains, really helps to control what our weather is and what our climate is here. So we have the Gulf out to the southeast of us. We have the mountains that are out to the west. So East Texas both benefits and endures the tropical weather systems and the rain that they bring, while we occasionally experience the remnants of those tropical systems, as I mentioned, but again, not very often. So we are in what's called a rain shadow. So we are on the, in case you can't see it, if you have people on the right-hand side of your screen, you can minimize that at the top, I think. Clicking on it, it's because I'm sharing my screen that I can't do that. So on the far right-hand side of the screen, it's identified as a rain shadow. So just a graphic representation. What happens is as the air that's carrying a lot of moisture comes in off the Pacific, from the west to the east, moving from the Pacific onshore, it carries a lot of moisture. And as it rises, as it encounters the mountains, there's coastal ranges, there's the Sierras, and there are the Rockies, that air is forced upward. And as that happens, that process results in the air expanding, which results in cooling. And so a lot of that moisture precipitates out of the clouds on the west side of the mountains. So by the time the air arrives here, a lot of the moisture typically has been removed from the air. So we're getting dry air often that moves into the area. By the way, dry air, when the humidity in the air is low, it increases soil evaporation. So the moisture in the soil is depleted more quickly. And when that happens, we typically end up with hotter days because, again, when we have a drier air mass, that tends to heat things up. As the days get hotter, that pulls more moisture out of the soil. So a cycle can develop, especially as it has this year with the drought conditions. We've had a hot summer for the most part, and it's been dry. So it's a cycle that kind of just feeds on itself. The dryness leads to more heat, the heat leads to more dryness until we get at least a change in that overall weather pattern. So this map is another map that's pretty messy to look at. But while I was recuperating, I put some of these graphics together and I wanted to get a little bit more detailed, but stay with me here and we'll try to go through this one. So in what we would call a good year, that is when we have at least normal precipitation, high pressure will develop over the southeastern United States or out over the, well, that's not what I intended to happen. I'm not seeing, okay, there's my cursor. One more time, try to back up to this graphic.
Hey, Steve,
Yes.
we're going to run out of time in about 6 minutes. So we'll take a short break and I'll re-invite everybody to a new meeting
Okay,
through email.
thank you.
All right. I don't want to pay their charges. They're very expensive.
Yes, I understand.
Thank you. Keep
But
going.
it keeps the meeting shorter.
True. That's true. So go ahead.
Okay, so the high pressure area, it's, oh, can you see my cursor on the screen right now? On the, no?
Yes.
Yes, you can? Okay.
Yes.
Yes, sir.
So this is often called a Bermuda high, and sometimes it'll shift a little bit more to the east and end up over the southeastern United States. The circulation around the high is clockwise. So what these arrows, the light blue arrows down here are showing us, again, is the flow coming in off the Gulf. Now, the green represents a tropical system, and the circulation around that high is what steers those storms so often through the Gulf and then into Southeast Texas, Louisiana area at times. So that's kind of more of the summertime pattern, and that's the pattern that we've really been experiencing this year with a strong high pressure area. Now, also the red line with the arrow on it, subtropical jet, if we get a subtropical jet, it can bring in a lot of moisture, and that can bring us even more rain. Then the blue or the purple line, that is the polar jet stream. So in the winter time, we are looking at a polar jet as opposed to that subtropical jet. And that big dip right around the Lone Star State that shows up there, that's what we would call a trough. And that's what allows some of that really cold air to move into the area. You may remember in September, we had that cold air outbreak with the high temperature of just 41 degrees one day. Well, that was the pattern that we had on that day. Kipper, do you want to go ahead and take the break now? Can't hear you.
Okay, everybody, look at your email. I'm going to set up another meeting so we can continue. How much longer do you think you have, Steve?
How much longer do you want me to go?
Oh, that's up to you because you're doing this for free. So,
Okay, well, let's just say we'll probably go another 20 minutes
Okay,
and then
great.
try to leave time for
All right.
questions.
everybody, tune in 3 minutes. I'll send out another email. Thank you.
Bye.
Bye.